In this lecture we are going to learn what an IDE is. We are going to learn how to write a C program. Then we are going to look at the general structure of a C program and the input-output functions, how to use them in C programs. And the following programs which we are going to look at are the area of a rectangle and how to exchange values between two variables. Now we come to a stage where we can start writing a C program. But before we start writing a C program, we need to know how to write it. So to write a C program, we need two components at least. The first one is an editor. Like a notepad, you have to write your program in that. And another thing we need is a compiler. Remember, we studied compiler in previous lectures. A compiler is a tool that converts your high-level language, like the C programs, to the low-level language, which the machine understands. Now, using two software is a bit difficult. So what people thought was to combine these softwares and form a new software known as IDE. Apart from an editor or a compiler, you also have some other tools like debuggers. So you combine editor, compiler and other tools and form an IDE, which is nothing but an integrated development environment. Integrated development environment. Now there are a lot of IDEs available. Let me list a few examples here. One IDE which was most popular was Turbo C, which is unfortunately used in colleges these days. Turbo C is a very old compiler. In my opinion, you should not use it because it's very old. Another example of an IDE is the Visual C++ IDE. Now Visual C++ you should use because first of all, it's a new product. It's always updated and it's free. It's provided by Microsoft. And if you're on Windows, you can use Visual C++. If you're on Linux, there is a tool called as GCC, the GNU Compiler Collection. This is also an updated compiler. It is recommended. So we are going to use the Visual C++ IDE. Now let us try to understand how does our program gets executed. How does it get called? How it is executed? So we have our operating system. Everybody knows what an operating system is. It manages all resources of a computer. You have your program. Now your program is not going to magically run. When you double click your program, it gets executed. So ultimately, when you double click your program, the operating system calls your program. And when your program gets executed, an operating system expects something from your program. So your program returns something. So the concept is that it's a call, give and take relation. An operating system calls your program and your program runs, does everything, does its operations and returns something to the operating system. Now there has to be a point from where your program starts its execution, because the operating system must know from where your program should start its execution. So you should remember that our programs always starts from the main block. There is a block known as main, which we'll study in a while. Main. This is the starting point. And your main program at the last statement returns something. So that's it we need for writing a C program. Now let us try to write one C program. So first of all we need some problem statement. So the question is how to calculate an area of a rectangle. Calculate area of a rectangle. So we have a rectangle here. Its breadth is 5 and length is 10. Okay, and you have to calculate the area. Such a simple problem, but what the problem specification gives is very important for us. This which is given is data for us. And how to calculate area we know is length into breadth. So this is our operation which we will be performing. So we have data, we have the formula, and what do we need to store data? We need variables to store data, right? We studied this earlier also, that data is to be stored in variables, and variable is nothing but a memory space given some name to access it. So in the following way we are going to approach solving of our program. Firstly we are going to start our program, so that we are going to write the main function, main block. Then we are going to declare variables, because variables have to be declared. So declare variables. What variables we need in this program are length and breadth. So we choose the same names for our variables, length, breadth. Now when you calculate the length and breadth, and you'll store this in area. So area is also data. This operation will also give you data. Now this data has to be stored, right? So this data is stored in area, the variable area. So we need another variable to store our answer. So we need 3 variables. So this is declaring variables. After that we have our formula ready, that is area is equal to length into breadth, right? This we have. But after you calculate the area, you need to display the output. You need to show the user that this is the area we have calculated. So we do nothing but print area. Print area. And it's an input-output operation, so we write it in parallelograms and then stop. So this is the approach we are going to follow to write our program. Now let us go ahead and start writing our program. The first thing we have to do is to write the starting point of our program. So we have the main function which is needed so that it defines the entry point of our execution. So we have the main function, main block. Any block is enclosed within a set of parentheses. Now our first task is to declare variables. So how do we go about declaring variables? Is very simple. All these variables, length, breadth and area, are integers, right? Length stores 10, breadth stores 5, and area 10 into 5 is going to be an integer. So we declare our variables as integers. So int is the keyword which declares, which is the type of variables. So int length, int breadth, and we have length, we have area, right? So we have declared 3 variables. Now the second thing to go about is to initialize some of these variables, because we need data. So this time we are not taking it from the user, we are directly giving the data in the program itself. So length is 10 and breadth is 5. Now one thing that is very important is this semicolons. You see, we have these semicolons everywhere in the program. Now a semicolon is something which corresponds to a full stop in English. Semicolon is nothing but a statement terminator. Whenever a statement terminates, you have to terminate it using a semicolon. Not necessary that a semicolon should always be at the end of a statement, end of a line, I mean. You can also have this, like this, length equals to 10 semicolon, so that the compiler knows that this statement ends here and the next statement starts. So, but it's better to keep your code clean. Now we went about initializing length and breadth to 10 and 5. The next thing is the operation area is equal to length into breadth. So we'll write this, we'll store the area is equals to length into. Now multiplication in C is done by the operator asterisk. You cannot have X like sign there, you have to use asterisk. Length into breadth. Right, we have done this much. Now the thing comes is to print the area. To print the what we have calculated, you have to print that. So the last statement is printing. Now printing is done with the help of a library function which is predefined by the C language. C language provides us this function printf to print some output. So print the area is, now we are going to print area here. So the area is, now it has a format, particular format. I'll explain what this format is. For now, remember this, that you have to write this way. This I'll explain in a while. This is called printing. Now we studied that in just a while ago, that you have to return something to the operating system, that your operating system calls your program and your program returns something to the operating system, like this main, and at the last you have to return something. Now you go about returning something from this program. So if you don't want to return something to the operating system, leave it as it is. In this program we don't want to return anything to the operating system. But if we don't want to return anything to the operating system, we have to write void before main, so that the operating system knows that when it calls main, it knows that it does not have to expect anything in return from calling this program. So if you return some integer, so you have to write int like this. If I return an integer, so if I return something, return 0. 0 is an integer, so you have to write an int before main. So in this program we will return 0. Okay. Now a small thing remains, that you have to include a header file. #include stdio.h. These files are called header files. Now header files are nothing but which contain some definitions about printf and other library functions. stdio stands for standard input output header. You have to include that to make printf work. If you don't include stdio.h, you cannot use the function printf. So stdio.h makes available the function printf. So you always include library header files here at the top of main, so that before starting your program, the compiler always includes what we have to use in our program. And this is the output which we have got. The area is 50, and after that press any key to continue. So look, area is equal to length into breadth, 10 into 5 is 50. So we have got a correct answer. Now let us understand our program properly. So first thing, we have to include the standard header file, the stdio.h, standard input output header, which makes available the printf function, the input output functions for us. After that, we go on by writing the main function, which is nothing but a starting point of our program. So main function is starting point of our program. Now we declare variables, because variable has to be declared of its type. Now we initialize variables, variable initialization. Okay, then we have our computation, and after that the output. And then the operating system expects something, expects this type from our program. So we have prefixed the main function with an int. So the operating system is expecting an integer when this program ends. So we are returning an integer. So this way our program gets executed. So the general structure of our program is the starting point, then declare variables, initialize variables, which means that we have to give some values to those variables. This also includes input from the user. In this program we have not inputted anything from the user, but you can input from the user. Then computation, and then output. Now let us look at this printf function. Now we have written printf and opening and closing parenthesis, the area is, and %i. Now what is %i? %i is nothing but a format specifier. Because the printf function does not know the type of area, we have to tell it that we have to print area at this place. And how do we want to print it? So we say that we want to print it as an integer. So %i is nothing but an format specifier for integer, right? And it acts like a fill in the blank. If you write printf, you have some text here, dash, and then %i, and then you have some more text here. After that, remember that text is combined with format specifiers and returned within quotes. So this forms the first argument to the printf function. This is the second. This is the first argument, this is the second argument. Now after the first arguments you have a list of variables, right? And according to the list of variables it gets printed. So we have a variable here, and this variable is inserted, the value of this variable is inserted wherever it finds %i. If we have another variable here, so it will print that another variable's value in some other %i, right? Now printf has a specified format. So let me write it so that you understand it more properly. Printf, now we have here text combined with format specifier. And after format specifiers, after this first argument, which is in double quotes because it's a string, it's a multi-character constant, and after that we have to specify a list of variables. If you have one variable, it assumes that here there is only one format specifier. If you have 2-3 variables, here must be 2-3 format specifiers. Now let us arrive at a very easy concept known as comments. Now you know what is a comment. People comment on each other, but comments aren't useful for the compiler. comments are always ignored by the compiler. Ignored by the compiler. Right? And a comment is only for us, the programmers. They are only for programmers' understanding. So programmers' understanding. Now how do you write a comment? Any comment in a C program is enclosed within a pair of /* and */. So you can have comment inside these comments. So comments enclosed within */ and /* can be multi-line. And there is another type of comment which is a single line comment. Single line comment. Now you don't have to close this. You put 2 slashes one after another, and the line which follows these 2 slashes becomes a comment and is always ignored by the compiler. Now let us know how do we write the comments actually in a program. So we have our program already written. So let me demonstrate what is a multi-line comment. So multi-line comment starts with a /*. So this is a multi-line comment. So this is not a multi-line. Let me put it in another line. So this is a multi-line comment. We can have 2-3 lines. Another is a single line comment. This is single line. Single line comment. Now you should put comments to use in your program. So first thing you can use a comment in a program is to have your name in the program. Look, everything has become a comment because you have not provided a closing sign for the comment. So inside this you can write your name. Then you can also write last modified date. Last modified on 19th November. So this way you can use comments to improve the understanding of your program. This is declaration. This is initialization. This is operation. And this is output. So this way you can use comments so that other people, when they read your program, they know what is happening in your program. So this is how comments are done. Now there is some problem with comments. You cannot have multiple comments inside each other. So you cannot have comment inside a comment. So nesting is not allowed. Nesting is not allowed. Now let us try to nest some comments and see that if it works or not. So we have a comment here. So we try to nest another comment inside this. Okay. So this is a multi-line and we try and put another comment here. Look, this comment has been moved out of the previous comment. So you cannot have nested comments. If I run this, then it will show an error. Look, there were build errors, right? So you cannot have nested comments. Okay, now this is all about comments. Let us go back to our program and see if we can improve it more. So we can have some input from the user, right? We have initialized these variables here already. So we can have, instead of initialization, we can have input. So remember that any C program is executed sequentially. First it will declare variables and then it will sequentially follow your statements, instructions. So we can ask the user to input the data, right? So first of all, to ask the user, we have to tell him to input his data. So we print it. So print enter length and breadth, right? Enter length and breadth. Give a space here so that it's easy for the user to enter the length and breadth. And then after this printing, we have to take input the length and breadth. So to take input, like to print, you have the printf function. To take or scan input, you have the scanf function. Scanf. The scanf function is used to take input. So as the intelligence feature says that int scanf const char star format, it requires a format specifier, because scanf needs to know what format of data you are going to input it. So within double quotes we input the format. The format is %i. We have to input two variables, right? Length and breadth. So we put two %i's here, %i and %i, and then comma, and after that we have the list of variables to be inputted, so that the first data which comes through scanf goes into the first variable, second I goes into second variable. So firstly we wish to take length, and after that we wish to take breadth. Now scanf does not need a list of variables. It needs the addresses of that variable. So it needs a list of address. So to give the address, just precede that variable's name with an AND operator. Now AND gives addresses. Why scanf needs addresses? We'll look into it in the later chapters when we study console input and output. But for now, remember that scanf always needs an AND operator, always needs an address, which we'll get using the AND operator. So AND length gives the address of length. Address of length means its location where it's stored in the memory, where the memory space is reserved for this data. So this way you can scan the input. Now let us run this program and check whether this works or not. So it says that there were build errors. So what build errors are there? It shows that print identifier is not found. So this, we have a spelling mistake here. It should not be print, it should be printf, because print is not understood, is not there in the C library. Printf is there. So printf, now it will work, I think. So the program is up and running. It is asking for enter length and breadth. So we first enter the length. Let us enter length, this time 4, and after that when we press enter it goes to next, enter 5. So 5 into 4 is 20. The area is 20. So this way our program works. Now the program is generic, right? It can calculate the area for any value of length. If we try and run this program again and try some different values, 10 and 20, now it gives different answer, right? So our program is now foolproof. Now let us write another program. The problem specification says that we have two variables, A and B, and you have to exchange their values, right? So our program is exchanging values, exchanging variable values. So how would we go about solving this problem? If you directly say that put B's value into A, now A's value is lost, right? So if you store B in A, A's value is lost. Same is the case with B, right? If you put A's value in B, B's value is lost. So how will you solve this problem? The simple solution is that use a temporary variable. Temporary variable. So the following animation shows you that how to use a temporary variable. So we have two variables, a and b. Let's say we have the value 9 in a and the value 5 in b, and we take a temporary variable. First thing we would do is to shift the value of a in temporary register, in temporary variable, right? And then move the value of b into a, and after that move the value of temp into b. So this way we have exchanged the values of a and b. So the process is like this. First, save a. The second is move the value of b into a, and then we have the a's value into temp. So we have saved value of a, so move that value into b. So b temp. It's such a simple process, right? Now let us try to convert this process into a program and see it in action. So we start off by including the header file #include stdio.h, the standard input output header. Then this time we are not returning anything from our program. So if we are not returning, so we have to write void. Void means literally nothing. So we are not returning anything from our program, so void main. Then we have three variables to be declared. First is a, second is b, and the third is temporary variable, which will be used to exchange the values between a and b. So int a, b, and temp. So we have three variables. Then we have to ask the user to input the values of a and b. So we first of all print that enter values of a and b, and then scan that input. So we print a and b, right? Then after this the user will enter these values. So we have to collect, we have to scan those values of a and b. So scanf. So here comes the format specifier. So a and b both are integers, so we'll put %i. We have to input two values, so a and b, so %i and %i. And we'll close the quotes, comma, and then the second variable, the second parameter for this scanf function is the list of addresses. So we have to pass the address of a and the address of b. So these two addresses we have to pass. Now comes the process of exchanging the value of these variables. So here we comment so that another person who is reading this program may understand what I am doing. Okay. Now what I'll do is to first to save the value of a into temporary variable. So temp equals to a. I've saved the value of a. Saving a. Okay. After this, put the value of b into a. So a equals to b, and then put the value of a which was saved into b. So b equals to, here we don't have to write a, we have to write temp because we have saved the value of a in temp. So thus the value has been exchanged. Now we have to print the exchanged values. So again we do that using the printf function. Printf, so a is equal to, now comes fill in the blanks, the format specifier. So %i, here the value of a will go, and b equals to %i, here the value of b will go, and we have to pass a list of variables to printf. So the later arguments, later parameters for printf function will be a and b. Now this a will go in this percentiles place, and this B will go in this percentiles place. So A goes here, B goes here, because the first I corresponds, the first format specifier corresponds to the first variable in the list. The second I corresponds to second. So this way we are exchanging the values of two variables. Now let us run this program and check whether it works or not. Okay, so we have our program up and running. Now it is asking for values of A and B. So we put value of A as 5 and B as 8. You see, the value of A is now 8 and B is now 5. So our program is working perfectly. So this is how you write programs in the C language. Now that's all we have in this lecture. Thank you for listening. If you have any queries or any suggestions to give, you can contact me on this email address. Thanks for listening.